Alright, so the last lesson for Unit 4 is called the Fundamental Theorem of Algebra. Okay, the Fundamental Theorem of Algebra, I have it written for you here, but basically what it says is, if you have a degree polynomial, let's call it degree n, remember it could be, I don't know, a third degree polynomial, fourth degree, whatever the highest exponent is, and it has, whatever degree it is, that's how many roots it has. Okay, now when we talk about roots, you have to look at what a root means. A root or a zero is where the polynomial is equal to 0. What that means is, whatever the root is, if you plug it back into your polynomial, you should get your function equal to zeros. Sometimes when this happens, we need to have complex numbers to have the roots. Okay, and we'll go through some of those examples. A complex number is anything that has the I in it. Okay, like that. Okay, it basically has the I. One way that we get complex numbers is when you have quadratics and you have square roots. We did this in Unit 2 and all that. But in this unit, we're not actually going to find the roots. We're just going to be interested in the type of roots it has, if it's real roots or complex roots. Okay, the good part about real roots is that you can actually see the roots on the graph. You can see the x-intercepts, and then which takes you to the bad part of imaginary roots is that you cannot see the imaginary roots. Okay, so we just have to depend on the real roots, and then we can calculate how many real roots it has, imaginary roots. So to do that, what we're going to do is we're going to take our function and we're just going to plug it into our graphing calculator. Okay, so we're going to go to our graphing calculator. We're going to first figure out how many real roots it has, because that's the easy one. You can just plug it in here and see how many roots it has. Oh, before I keep typing this in here, just think about the degree of the polynomial, which is a 4, which means that it should have a total of 4 roots. Okay, so let me keep typing this. Plus 2x cubed minus 8x squared minus 48x minus 64. Alright, well, here's the graph of this polynomial. It looks something like this. And if you notice, you see 2 roots here. You see 1 root and -2 and 1 root and 4. I don't care what the actual roots are, but I do see that this only has 2 roots. Okay, so that's what I'm going to write here. It has 2 real roots. And remember that imaginary roots, we can't see them on the real number line, but we can kind of calculate them depending on the real roots. So if there's 2 real roots and there's 4 roots total, which means the other 2 have to be 2 imaginary roots. Okay, 2 imaginary roots. And that's all I'm going to have you guys do in this unit. I'm not going to have you calculate the roots for me, do all the solving stuff, but we're just interested in the type of roots does this polynomial have. Okay, let's try number 4. So all you're going to do is, if you're asking for the type of roots, you're just going to plug your function in here. This one, that's why I want to try this. Okay, when we are plugging the function here, we need to make sure to have it equal to 0 to be able to see the roots. So this is not equal to 0, but I can make it equal to 0 by just taking the negative, or this term, over to the other side. So you would have 0 here equals 0 here. Okay, and then on the left side you have 5x minus 5x cubed, and then minus 36x. Here's your function. Alright, so the degree of the polynomial here is 5, so it should have 5 roots. Okay, all I see are 1, 2, 3 roots. So, and I'm going to make a note of that. It has 3 real roots, which means the other 2 have to be imaginary roots, because 3 plus 2 gives you your 5 roots. All right. Something you have to know about imaginary roots or complex numbers is that they only come in even numbers. Okay? They only come in even numbers, the plus or minus, the imaginary roots, or if you have roots that have square roots, they come as plus or minus. Okay? So you'll have problems on your test where they'll give you a complex root, and you have to come up with the with its pair. We call them pairs. So just know that when we're trying to find its pair, we do not, this is the real part, right? This is the real number. You don't change the real number, you only change the imaginary part. The real part and the imaginary part. You only change the imaginary part. So the real part, you keep it the way it is, -3, and the imaginary part, since it's positive 3i, you have to write down the -3i. Same thing for irrational solutions. This is an irrational solution. So since this is a positive irrational, you have to do the negative irrational solution. Okay. Let me do another example. This one right here, this is not imaginary, nor is it a complex number. Or, I mean, irrational. So this does not have a pair. So you just say no pair. It's just -3. But this one does have a pair because of the irrational part. So you're going to do 3. Don't change the real part, only the irrational part. Oops. Subtract square root of 3. Okay? And then we have some more questions here that you'll see. Just know whenever it's asking for a zero of a function, let's find this. It says find the zeros of the polynomial. So what you're going to do is, I would just check to see if it's zeros by plugging it back in here to see if you get 0. So to do that, I'm going to take, let me do a split screen. Okay, I'm going to take my calculator. I'm going to take the first 0x, which is -2. I'm going to plug it back in here. So I'm going to use parentheses. So you have -2 cubed plus 2x, well, x is -2. I'm just checking this. Oops. 2 -2 to the second power minus x is -2 minus 2. And I'm interested to see if it gives me a 0. What did I just do here? I took my answer choice -2 and I plugged it in here. Okay. I just used parentheses. So for x, I put -2. Okay, let me track it out. Oh, -2 to the third power, right here. -2 to the third power plus 2, -2 to the second power minus -2 minus 2. So many 2's. And that calculates it to be 0. So we can say that this is a 0 of a function. Okay, now we have to check this one. So what I'm going to do is I'm just going to take out the negative, make all my -2 as positive. See if it gives me 0. Nope, it doesn't give me 0. It gives me 12. So we can say that this is not a 0. So it cannot be A. Let's check 4. Let me change all this to 4. That gave me 90. That didn't work. Now let me check -1. Yep, that gave me a 0. So this one works. We know that the -2 works because I checked it up here, which means that I just have to check 1. Take out the negatives. Did I give it 0? Yep, all 3 of these check out. So it's the answer choice is C. This one checked out. The one that didn't work was +2. That's why this one was out. So that's why D is out. So the answer choice is C. Oh gosh, that was ugly. Now I'm going to go through this final example here. It says find all the zeros. So to find the zeros, what I'm going to do is I'm just going to plug the answer choice back in. Unfortunately, the bad part about Desmos is I don't have imaginary numbers in Desmos, so which means that I'm going to do the same thing. I'm going to plug it back in for x, but I'm going to use my yellow calculators, which does have I in there. Okay, so and you can do this. You could have done this part in this calculator as well. Okay, so let me get my screens ready. Okay. All right. So to this question, hold on. So it's asking me to find the zeros, and what you're gonna do is, since we have some answer choices here, we're just gonna plug it in and see if my function gives me a zero here. So my first zero here is x equals 5 plus 12i. So I'm gonna watch how I do this. I'm gonna do well, I'm going to do it two ways. The one way is putting it in parentheses. Parentheses, my x here is 5 plus 12i. 5 plus 12i. And then to the third power right here. Plus 10. And then my x here is, again, 5 plus 12i. Squared. Plus 169 to the parentheses of 5 plus 12i. Do you have to use parentheses? Yes, 100%. You have to make sure to put parentheses for your x. Hit enter. And nope, I did not get 0, so this does not count. Okay, so I don't like doing it this way in this calculator. I like to use the store button, which basically tells, if you can tell the calculator what to store for x, then it'll calculate it for you. So for example, for this one, my answer choice here is negative b plus 12i. What I can do is I can just say negative b, let me clear all this out, negative b plus 12i. What I can do is I can store this number for x. Okay? What that does is it makes your x equal to whatever you plugged it in there. You can look up here and see what x is equal to. So whenever I press x, it's going to read it as whatever you plugged it in there. So what I can do now is I can just plug this whole thing in here, x cubed plus 10x squared plus 169x, and if you hit enter, what your calculator does is take all of this and plugs it in here for you. That way you don't have to worry about parentheses and just typing it all out. It's just way too much to type. Look, it's up here. So again, if instead of typing all this up, you can just use the store button. If you want to understand how to use the store button better, just let me know and I will go through it with you. And trust me, it'll make your life so much easier. Anyway, that one works, but I have to make sure that x equals 0 works too. So let me use the store button for that. So I'm going to choose 0. I'm going to change the x to equal to 0. So you have 0 store for x. I'm going to check my function again. And that gave me 0 as well. So both of these are zeros, or my roots, because when I plugged it back in, they gave me zeros. Alright? Alright guys, turning points. The turning point is where your function is changing from increasing to decreasing. So let's quickly graph it and see what the turning point is. X to the 6 plus 8x squared. And you hit enter. Oh, you hit graph. There's your function. I'm all trying to zoom in like I do on Desmos. Ugh, this is such a chore. Hold on. Okay, so turning point is where your function is decreasing to increasing to decreasing. It goes back up, or if it's decreasing, it goes back down. You'll see a turning point. On this one, this is not a turning point because it's decreasing, and it still keeps decreasing. So we can say 0 turning points for this one. Okay, let's check the next function. We'll just plug it in. 5, I'm going to do this one on Desmos. I'm sorry, I just like typing on Desmos way easier. So for Desmos, I have the function is 5x minus 5 squared x squared minus 1, and then x plus 1. Okay, so looking at this function, looks like there's a turning point here, 1, and then there is no turning point because it keeps increasing, so there's only one. Well, you see 1, but don't forget that there's another one here, so if you want to zoom out. Okay, so there's a turning point here and here, so 2 turning points right there and right there. So you would say 2 turning points. Okay. Let me know if you have any questions.